Hello everyone, welcome to Pepcoding. Today we are here to solve a question named Crossword Puzzle. Okay, so this question have a very big name in the market. Okay, so this question is going to be very interesting. Please pay attention to this question. Okay, so now in this question what we are given a 2D array of 10 cross 10. Okay, and in that array we are filled plus and minus. Okay, and minus represent that there is a vacant space, we can fill our words there, and we are given some n number of words that we have to fill in that crossword, that 2D array that is a crossword, right? Okay. So let's go on the board, discuss this question in depth. After that we'll try to code this problem. Yeah, everyone says that this question is tough, but we are going to break this question into many parts. So what will happen, this question will become easy. Okay, so what is the motive of this question? In this question we have to place given words in this given crossword, right? So first of all, what do you think what we need? We need the starting point to fill the crossword. So starting point is this, right? Wherever we see minus, that is the place where we can start filling our crossword, right? So first of all, we will choose the word that we want, right? Let's suppose we choose London, right? So what will happen? We will start traversing on this 2D array. So wherever we got this minus, what we will think there is a space, we can fill our word, right? So this is the starting point. This is not the final that we got minus and we start filling, right? So what is the condition there? We got the starting point. After that we have to look for two conditions. What are these two conditions? First, if we can place it horizontally or we can place it vertically, right? If we reach this point, we seen minus, there is a vacant space. Now we will consider we can place here horizontally or vertically. If it is possible to place horizontally, we will place the word horizontally. If it is possible to place the word vertically, we will place the word vertically. And if it is possible to place the word both the direction, so we'll place it in both the ways, right? Okay, so it is possible that we can get multiple answers out of it. How? Let me show you. Just suppose minus plus plus and okay, so minus plus just suppose this is the crossword, right? And you are given two words and right? So there is a possibility and can be filled like this and can be filled like this as well, right? And there is a possibility and can also be filled like this and this, right? The same thing. So there can be multiple possibilities, right? So we'll check for both the condition. Actually, this is not the perfect example for this. This is for multiple answers. The perfect example for checking that we can place the word vertically and horizontally is this: dash 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 plus. Now we have the word and to fill. Now what do you think? And can be filled like this as well and like this as well, right? So at this place when we reach, we will consider both the conditions. We will place it vertically as well and horizontally as well, right? Okay, so this is the perfect condition to explain this, right? So what do we have to do? We have to start from choosing a word, then we have to traverse on this 2D array, and whenever we got this minus place, means vacant place, what we will do, we will start placing our word. We will first check if it is possible, then we will start placing our word, right? And there is one more condition in which we will place our word. What is that? Just suppose in the first condition we placed our London here. Okay, this is placed. After that we started with Delhi. So when we started for Delhi, we again start traversing here. We reach here now. So what we'll do, we got the first word of Delhi D here and some vacant space. If we get the first word matching, we will check, can we place it horizontally? So we will get a space of Delhi here, right? So we'll place it. We will check for vertically as well, but we see that it's not matching. Here it is O, so we can't do it, right? Okay. So here we are having Delhi, so it will be DLHI. So there are two conditions for start placing the word. First, we get a blank space or we get a matching word, right? Okay, this is good. So first of all, let's go and code part by part as we are discussing. So first of all, we have to choose a word. So we are here on the editor. What we have to do first, we have to pick a word, right? So our word is a vector which is containing all the words. So first of all, Let's make a string word which will be equals to words of idx, right? So we got the word out of it. Okay, we are having a word. Now we have to check where we can place this word, right? So for that, we will start traversing on this 2D array. Actually, if we draw a recursion tree for this problem, what will happen? Just suppose we will have to look for 200 conditions. Can you imagine why? Because we have to place 100 places. It's a 10 cross 10 matrix, 10 cross 10 array, right? So 100 possibilities are there, and we have to check at every position for two values, for vertically and for horizontally. So there are 200 possibilities, right? Okay, so let's go. First of all, we will start traversing. For int I equals to 0, I is less than 10. Okay, I plus plus. After that, what will happen? We will look for one more loop, and j equals to 0, j is less than 10, j plus plus. Okay, this is also done. So inside this loop, what we are going to do? Just suppose I and j is 0 0, so we are at 0 0. So we have to check for we can place, there should be a vacant space or a value that is matching to our first word, right? So we will check that condition first. If the value of ARR, okay, we are having some network issue. Okay, right. So ARR IJ, right? IJ. Okay, this should be either equals to minus. It means it is a vacant space, or the second condition is it should be the starting word of that word that we are having, right? So ARR IJ should be equals to the word 0. It means the first word, right? So if this is a condition, it means we got a starting point. We can start from here, right? So now inside this, we will check for two conditions. Can we place it horizontally or can we place it vertically, right? So we will check both these conditions. Just keep it abstract for now. We will complete these functions later. The functions that we are going to use here. The first function that we are going to use, can place horizontally. Okay, this is done. Now, okay, inside this, what we are going to send? We are going to send our array and I and j and the word, right? So if it says yes, it means we can place, and if we can place, then we will place. So place horizontal, right? And inside place horizontal, we will send array I, j and the word, right? This is done. And one more possibility that I have explained you here, like in that condition, when we are having this condition, so what happened? We have two words, and, right? So there is two possibilities, and can be here and can be here, right? But there is one more possibility. What is that? And can be here or and can be here. For that, we are using backtracking. Actually, we can have multiple answers, right? So whenever we place, we will unplace it also when we are coming back. So unplace horizontal, and inside this ARR I, j and my word, and between them we will make the call for our solution. So solution ARR, and we have a vector of words that will be here, and we have placed one word, so we will actually increase the value of index, right? Because we have to choose for next word. One word is already placed. If we are here, it means it is placed, right? So we will increase the index so we can look for the next word. Okay, so this is good. Now what we have to do, we have to take care of one more thing here. Let me tell you. When we make a call, we have placed London vertically, right? After that, we place Delhi horizontally. There is no problem in placing the words. When we are backtracking, then there will be problem. Like when we are backtracking, actually we are replacing the words again by minus. We are making the place vacant again to check other possibilities, right? So here one problem is going to happen. What is that? If we are unplacing Delhi, we will unplace this D as well. So our London will be broken from between, right? So this is not good. We have to consider D as one. Like if the D came with London, so D will go with London as well. So for that we need a track. We need to track them. So how we are going to do that? We are going to use a Boolean array for that. Okay, Boolean vector. So first of all, let's go make a Boolean vector here. Okay, and visited, right? And its size will be the size of word dot length. This is done. Okay, our visited vector is ready, and we will send it while placing. So visited is also going with you, man, and here also, right? So this is done. Now this is for horizontal, and the same code is going to happen for vertical as well. So we'll just simply going to copy it and going to paste it. We just have to make some small changes here. Can place vertical, and here also, then place vertical, TICAL, right? Then unplace vertical, TICAL, right? Here RIJ word and visited. Okay, so this is the plan. This has happened. Okay, now we have to take care of the base case for this recursion call. Don't worry, we will complete all these 6 functions: can place, place horizontal, unplace horizontal, place vertical, can place vertical, and unplace vertical. Okay, but first of all we need to complete this function. So what is going to be the base case for this recursion call, for this recursion solution call? What is going to be? Just suppose this is the crossword. When we will stop when we place all the words that is given to us, right? Exactly. So that is going to be the base case. So if the given index is equals to words dot size, it means we have reached to the end of the words array that we are having. So if it is the condition, what will happen? We will print our array, print our answer, and then we will return, right? Okay, so we have a pre-written print function here. We will just simply use that to print our this vector, this array vector, right? Okay, so this is done. This function is completely done. Now what we have to do? Now we have to complete all these functions: can place, place, and unplace, right? So this is going to be easy. If we write can place for horizontal, it is going to be same for vertical. We just have to make some small changes. Okay, so now let's go. So can place is a bool type return, right? So we have to make a bool function here, can place horizontal. Okay, so inside this, what we are having an array. So vector of char type, right? And this is array, right? And what we are having the indexes. So int row and int column, and after that we are having one more thing, that is word. So string word, and one more thing, that is boolean vector. So vector bool visited. Okay, this is done. Actually this is not for this. The visited vector is for while placing, not during this time, right? This time we are having only words, right? So we are here now. Now what we have to do? We have to actually traverse on that word that we are getting to check, can we place this word or not, right? So let's go. First of all, int I equals to 0. This is done. We will run a loop. I is less than under word dot length. Okay, I plus plus. So we are traversing on that word, and at the same time we will traverse on that array as well, right? So we can check, can we place this word there or not? Okay, so first of all, what we have to do, we have to check, does that our word which we are placing, is that not going out of the array, right? So if what we can say, we have to check horizontally, right? C plus I is greater than the words dot size, right? So if we are placing and we got out of the box, it means it is not placeable. We can't place this word, right? So we will simply return false from here. Okay, let me explain you this here. Like just suppose we are having this crossword and the given word is and. So we reach here, we got a vacant place. So what we happened? We start placing word and D got out of the box, right? So this is not possible. That's why we will return false for this condition. So this is done here. Now after this, when we will continue, we are going to check when we are going to continue. We are going to continue. Just suppose we are here, we got Delhi, so D will be placed here. So the next word, what it can be, if you have to place, something here, either this word should be dash or this word should be that word which we need to place there. Okay, can you get it? Actually, if that is dash, it means we will place our word there. And the second thing, if it is not dash, so it should be that word that is going to place, that we are going to place. So if it is already there, so our work is done, we don't need to place, but we will do. Okay, so the second condition that we are going to do is if ARR C plus I, oh actually here we will get R, and C plus I, what that should be? That should be either equals to minus, right? Or second condition was ARR or C plus I, it should be equals to the word of I. Did you get that? This is the condition in which we will keep continue checking, right, till last. Okay, else if this is not the case, it means we will return false. It means this is not suitable for us. Okay, now when we come out of this loop, we have checked for that all the condition. Now we have to check for, is our word completely fit for it or not? Okay, let's check how. Just suppose this is the vacant space we are getting. Okay, so definitely if we have to place Delhi, we simply can place Delhi here, DELHI, right? We have a space, we can check, but we have to check one more thing. Is it suitable? It is like perfect fit for it or not? So what does it mean by perfect fit? If it is perfect fit, so when the word start, above it will be plus and at below it will be plus, not this dash. So it will be perfect fit. Or the second condition is that from wherever our word start, above should be like out of the array. Like this is the starting of the array, it should be above of the array. This is accepted, no issue. And the second thing is accepted, our word end here and below we don't have anything. So this is also accepted, right? So let's go and try to code this. So when we get out of this, so if C plus I is equals to the length of our array, so ARR dot size, okay, or ARR of R C plus I will be equals to plus, right? So this is the condition in which we will return true. It means it is perfect fit. Else what will happen? We will return false, right? So this is done. Now what we are going to do, we are going to write for can place vertical. But do we really need to? No man, because the code is going to be the same. We just need to copy paste it and make some little changes, very small changes. Okay, so we are here, we pasted it, and we have to write the function can place vertical, right? Okay, now inside this, in place of column, we are moving in rows. So R plus I, the C will be same, R plus I, C will be same, right? Move forward, R plus I, C will be same, and R plus I, C will be same, right? So this is the condition. Okay, now can place horizontal and can place vertical is done. Do you see? It is that easy. Now what we are left with? We are left with place horizontal and unplace horizontal and place vertical and unplace vertical. So let's go. First of all, we will try to code place horizontal. Okay, so we are here. Okay, so this is the function of void type. We don't have to return anything. So place horizontal, right? Inside this, what we are getting? We are getting a vector. So let's copy RC word, and one more thing. What is that? Okay, that is the visited boolean array that we have. Okay, so let's make that as well. Vector bool visited, right? Okay, this function we have to complete, and here we will pass by reference. So ampersand r. Okay, so this is done. Now what we have to do, we have to place at horizontal, right? So for start placing, first of all, we need to run a loop. So for and I equals to 0 until I is less than word dot length, right? I plus plus. Okay, now there is one condition. We have to mark that condition, right? We have to mark the word which are getting placed with us, right? So if the visited I is okay, I missed something. We have to make changes here. ARR R and C plus I is equals to minus. It means it is a vacant place and we are placing our word there, right? So what we have to make our word true. That will be stored in visited, right? So visited I will be equals to true, right? And what we have to do? ARR R C plus I will be equals to the word I. Okay, this is done. Now what we have to do? Now we just have to copy and paste for place vertical as well, right? So let's go do that. We have copied this and pasted it. Place vertical, right? Okay, this is done. We are having all the same thing. What we need to do? We need to just play with R this time because we are moving in rows. Here as well, R plus I. Okay, this is done. Do you see? That much easy, right? Now what we are left with? We are left with two more functions. What is that? Unplace horizontal and unplace vertical. So let's go. First of all, we will try to code unplace vertical. Okay, so that is also a void type. Unplace horizontal. Okay, so now we have to copy all the same thing. The parameters are going to be same. Okay, and paste it here. Perfectly done. Okay, so inside this we have to unplace this time, right? So again we are going to run a loop for and I equals to 0, I is less than word dot length I plus plus, right? So this is done. Now what we have to do? First of all, we will check the word is used by ourselves or not. So if visited I is equals to true, right? It means the word is used by ourselves. So now ARR I C plus I, okay, will be equals to minus, right? This is done. This is all about this code only, right? Do you see? That much easy. We have to copy this code and we'll use the same code for unplace vertical as well. Okay, so copy V, right? Unplace vertical. Okay, this is done. Now what we have to do? We have to make some changes only. This time we will play with rows. R plus I, not C plus I. C will be same. Okay, do you see? That much easy. Okay, so we have completed all the 6 functions that we were looking for. Okay, so our code is complete. Now we just have to run and check this code, right? Okay, now let's go and run this code. Okay, it is having some mistake for int. Okay, some typing mistake, so it will be here as well. Okay, now let's see, this is having any other error. Okay, at line number 19. Okay, the same thing. Okay, at line number 49, line number 49 here, if r plus I is greater than words dot size or greater than and equals to as well, like, okay, so it means we are crossing the box. Okay, so this is also done. Some more error. Okay, if it is here, it will be here as well. C plus I is greater than or equals to. Okay, now let's see at line number 105. At 105 here, can place vertical. Okay, typing mistake, can place horizontal. Okay, it is all good. Now let's run it. Okay, we have some more error here at line number 49. Let's have a look. R plus I is greater than words dot size. Oh, okay, it is word, not actually word. Okay, okay, this is done, this is done. Oh, actually we are not getting the words, right? Oh, okay, let me see. Okay, number 49, r plus I is greater than words dot size. Yeah, exactly, it should be words dot size, but we are not having word here. Okay, so we have to check that as well. Okay, this is not the words, we have to check with the size of our array. So if it is here, it will be here as well. Here, right? So this is done. Now let's run it. So yeah, it is successfully accepted. Now let's submit it for all the test cases. So test case 2 failed. Okay, and 5, 2 test cases failed. Let's see why actually. Okay, so we found a mistake here. Actually we have written double equals to here. This should not be, this should be single equals to. Now let's run it. Let's submit it for all the test cases now. So yes, it is passed. Okay, so I hope you have learned something with this video. Please like and share the video and subscribe the channel. Thank you so much.